Alrighty, here we go. We're going to be solving trig equations. And they're going to come in all different forms. So I'm trying, hopefully I have examples for all of the different things that you could possibly see in your homework. Okay, so the directions are also different. Notice this says for all solutions. So we're going to have to handle that once we solve a little bit differently. So let's go ahead and let's solve this. So we need to get the cosine x alone on one side. So let's subtract 2. And then let's divide by -2. Okay, you could go ahead and you could take the inverse cosine of both sides. For me, that's just another step. I stop here and I say, okay, what does this mean? This means what angle has a cosine of -1? What angle has a cosine of -1? Well, the only angle that we have that has a cosine of -1 is 180 degrees. I just had tried to decide if I wanted to go degrees or radians. Since we just did a bunch of pi radians thing, I think I'm just going to go to degrees, and we're going to do pi radians for the rest then. So now, here is the deal. That is one solution. That is one angle that has a cosine of -1. But don't forget, that's this angle right here, correct? There are a zillion more. What if I go around and end up here? Well, that's the same angle. I just added 360. What if I do it again? That's the angle, same angle. I just added 360. What if I start with the 180 and I start subtracting 360? Aren't I going to get the exact same angle? So there are many names for the angle that looks exactly the same. So here's how I want you to write your solutions. Your solutions are the set of all x such that x is equal to 180 degrees. Now, how do I get to all of those other solutions? I keep adding 360 k degrees, where k is an element of, that's what that symbol means right there, is an element of z, which is the integers. What that basically means, remember, integers are numbers like 0, 1, 2, 3, -1, -2, -3. So when you write it like this, it's capturing all of the 180 plus all of the multiples of 360. If k is 0, it's just 180. If k is 1, it means it's 180 plus 360. If k is 10, it means it's 180 plus 3600. If k is -1, it means it's 180 minus 360, and on and on and on. So that is how we are going to write our solutions. And you only have to worry about this if it's asking for all solutions. All right, well, let's look at this one. So there are all different kinds of ways. Now, I happen to know that this is a quadratic. It's got a sine squared. So guess what we're going to have to do? We're going to have to factor. Lots of factoring for the rest of this chapter. So if I go ahead and if I factor it, it's going to be 2 sine x and then 1 sine x. And then it's going to be a 1 and a 1, so that's easy, but I just have to figure out where my signs are going to go. It looks like it's going to be a plus here and a minus here because I want a positive sine x in the inside. So there it is, factored. We need to take each one of the factors and set it equal to 0. And solve. So I just added 1 there quickly. So this is sine x equals 1/2 and sine x equals -1. Now, we're no longer in the restricted values thing. So there are going to be 2 different angles, one in the first and one in the second quadrant, because that's where the sine is positive. 2 different angles that have a sine of 1/2. There'll only be one angle that has a sine of -1 though. So just really quickly, if I just solve this, the first angle is 30 degrees. That has a sine of 1/2. And the other one is 150 degrees. And then for this guy, what angle has a sine of -1? Well, 270 has a sine of -1. And again, that's all unit circle. So now let's go ahead and let's write the answers because we have to do all solutions. So it would be the all x such that x is equal to 30 degrees plus 360 k degrees, where k is an element of the integers. Now we have to do the 150, all x such that x is equal to 150 degrees plus 360 k degrees, where k is an element of the integers. And finally, all x such that x is equal to 270 degrees plus 360 k degrees, where k is an element of the integers. Now the textbook might have a slight variation on that when you check your answers. Go ahead, check your answers. Okay, if you are watching a YouTube video to kind of look to see how someone else does it, they may have a slight variation on that, but it basically means the same thing. All right, so that's enough of that. Now let's go ahead and let's start solving equations where we have more of a restricted domain that we want to work with. So notice this one we're going to solve in pi radians, by the way, and it's all angles from 0 to 2 pi. So let's go ahead and let's solve this one. So it looks to me like the easiest way to do this is we're going to first add the 1. We're going to divide by 2. And now we're going to square root both sides because that's sine squared x, which means sine x is equal to, now whenever you square root both sides, don't forget you need a plus and minus. And if I do this and make it root 1 over root 2 and get the radical out of the basement, you'll see that that's simply going to be root 2 over 2. So 45 degrees should be in your head. So now, what are the angles? What angles have a sine of either, by the way, plus or minus root 2 over 2? So because I have a plus and minus here, there's going to be one in each quadrant. So what's the first quadrant angle that has a sine of root 2 over 2? Well, that would be pi fourths. And as I go around my unit circle, the second quadrant would be 3 pi fourths. Third quadrant would be 5 pi fourths, and 7 pi fourths in the fourth quadrant. And there are your 4 angles. All right, we're going to do something similar to B here. We're going to go ahead and we are going to factor this. So this would be tangent squared x and tangent squared x. It would be -1 and -3. So now let's go ahead and let's set each one equal to 0. So tangent squared x is equal to 1. And then if I square root both sides, I'm going to have tan x is equal to plus and minus 1. If I go to the other side, I get tangent squared x is equal to 3. And then if I square root both sides, I get tan x is equal to plus and minus root 3. So there are going to be 8 solutions to this equation. There's going to be 4 here, 1 in each quadrant, and 4 here. So let's do these 4 first. In the first quadrant, what angle has a tangent of 1? Well, that's pi fourths. And then going around, it would be 3 pi fourths. It would be 5 pi fourths. And it would be 7 pi fourths. Now if we go to this guy, what angle has a tangent of root 3? Well, in the first quadrant, tangent of root 3 means it's pi thirds. Then going around my unit circle, it would be 2 pi thirds, 4 pi thirds, and 5 pi thirds. And there you go. All right, let's look at 3a now. how does that change the situation? Well, it's already solved for tan, right? So what you're going to do is you're going to do the following. Instead of saying theta equals, which by the way, this is the same thing as having an x, you would have 2 theta is equal to. Now, what angles have a tangent of -1? Well, remember tangent is negative in those 2 quadrants. So this one would be 3 pi over 4. And then this one would be 7 pi over 4. But remember, 2 theta is equal to that. So now I would have to divide both sides by 2 to get my thetas. This would be 3 pi eighths, and this would be 7 pi eighths. So now, here's the problem. Notice the directions. Say I want everything from 0 to 2 pi. If I look at the second answer, this isn't even pi. 7 pi eighths is smaller than pi, because remember pi is 8 pi eighths. So here's what you have to do in this situation. Look carefully. So this angle, remember, was 3 pi fourths. I need to find another angle that looks exactly like that. So what I'm going to do is I'm going to take 3 pi fourths and I'm going to add 2 pi. Because remember, that just gives me another angle. Well, let's see. If I do that, I get 2 theta equals, if I get a common denominator here, this would be a 4 and this would be an 8. And you can see I get 11 pi fourths. When I divide by 2, that's going to give me 11 pi eighths. And yes, that is smaller than 2 pi. So that's another solution. I'm going to have to do the same thing to this one. So I'm going to take my 2 theta equals, and I'm going to take 7 pi fourths, so that's this angle. But I'm going to add again 2 pi. So 2 theta would equal, if I add those by getting a common denominator, I'm going to get 15 pi, over 4, not over 8 yet. And then when I divide by 2, I'm going to get theta equals 15 pi over 8. And that is another solution. So it's kind of a pain in the neck when you have that 2 with the theta there, because you actually have to come up with another whole row of answers by adding to your original angles 2 pi. If it's a 3, it's even worse. Let's just keep it as a 2 right now. All right, let's go to B. Looks again to me like we're going to have to factor, but I'm going to have to add 1 to both sides first. Got to set it equal to 0. Let's go ahead and factor. So 2 cosine x, 1 cosine x, 1, 1, and everything's positive. So if I take each of these and set them equal to 0, if I set the first one equal to 0, I'd subtract 1 and divide by 2, so I'm going to get cosine x equals -1/2. And if I take the second factor and set it equal to 0, I'm going to get cosine x equals -1. All right, so let's come up with our angles. Now cosine is negative, don't forget, in the third and the fourth quadrant. So I'm looking for a third quadrant angle and a fourth quadrant angle. So what angle has a cosine of -1/2 in the fourth quadrant? That's going to be, oops, I lied. My apologies. Cosine is going to be negative in those 2 quadrants. Hopefully you were saying, what is she doing? So my second quadrant angle is going to be 2 pi thirds. My third quadrant angle will be 4 pi thirds. And that's it for that one. And then what angle has a cosine of -1? There's only one, and it is pi.